Good morning, ladies and gentlemen. We are live at 5 a.m. and this is our binary day. How to learn binary. So, if you look at this image right here, this is the only thing that a computer knows. This is how a computer thinks. Every image that you see, every sound. This is the reason why we can use Wi-Fi. This is the reason why you can download something over the internet. Because it gets translated into zeros and ones. Without zeros and ones, we couldn't download something over the internet. This is the reason why you can, stream movies, shows, songs, videos. And the cool thing about it is it's a lot of zeros and ones, but guess what? We can get it exact. We can exactly reproduce these zeros and ones. Are you with me? All right. So you've seen that, okay? We've seen this picture here that we read, right? There are only how many type of people in the world? Two types of people in the world, not 10. Two types of people in the world. Those who understand binary and those who don't. So guess what? Today you go into that category of people that understand binary. All right? And then here's a nice one. Look at this. Hello, my name is. This is what you're going to do tonight for homework. Yes, this is what you see on price tags. Price tags are, they're not binary code, but they are QR codes, barcodes. And yes, barcodes are nothing more. Those black, there's one in the back of the room there. Barcodes are nothing more than numbers. Okay? And when the infrared light hits it, it's either hitting dark, thick, black, white. Can someone shut that door for me? Okay, so let's go ahead and start. Um, let's start writing some stuff down. Does everybody have note papers? Okay. Does everybody have a pen or a pencil? Paper doesn't help you if you don't have one. My computer's going really slow again. All right, so this is our binary code day. All right. So in binary code, we need to start talking about memory, okay? Because I'm going to start writing out that we just read the article, right, where everything is turned into binary, and the number of waves you have determines how many bits and bytes you need, okay? So first of all, let's write this down, okay? 1 byte, okay, B-Y-T-E, is equal to 8 bits. And what I want you to do is come over here and draw out like 8 dashes. 1, 2, 3, 4, 5, 6, 7, 8. And do you guys remember this image back here? Okay. We're going to put those ones and zeros in there. Are you with me? See all these ones and zeros? So 8 bits, 8 little dashes that contain ones and zeros is equal to 1 byte. Who's okay with that? Write that down. Okay. Not mind-blowing yet. Now, go ahead. we have something called a kilobyte. Has anyone ever heard of a kilobyte before? Okay. This is a kilobyte, which you might returned as, you might see it as a KB. Okay. Which is equal to 1,000. And I need to erase this. It's not really equal to 1,000. Okay. It's not really equal to 1,000. It's approximately equal to 1,000. Okay. What is it really equal to? 1024. 1,024 is really a kilobyte. Okay. Bytes. Okay. 1,024 bytes. Now, how many bits are in there then? Yeah. You would then, if you wanted to know bits, bits is equal to 1024 times your magic number of 8. Yeah, a lot, right? Okay. So you're always going to be multiplying by 8 today because there's 8 bits in 1 byte. Now, the next one is, you guys know, you have a megabyte. Okay, which is equal to MBs, which is approximately 1,000 times 1,000, which is 1 million. Okay, is it really 1 million? No, because it would have to be 1,024 times 1,024. If you guys want to have fun tonight, if you want extra credit, go ahead and multiply. Find out what they really are. Yeah, get a calculator out and do 1024 times 1024. I'm not going to do it for the sake of time today. You guys can do it on your own for extra credit. It's kind of fun. Okay, so this is 1,000 bytes. This is a million bytes. MB, just remember, mega is a million. Okay, next one. Gigabyte. You have a gigabyte, which is a GB, right? Which is going to be approximately 1,000 times 1,000 times 1,000, which is a billion. Okay, so you got 1. Is it really exactly a billion? No. You need to take 1024 times 1024 times 1024 to get how many gigabytes you have here. Okay? What's that? No, the next one is, and I always spell this wrong. Let me go out here and go to Google real quick. And let's type in TER, terabyte. I don't know if it's 1 R or 2. Nope, I was right. It's 1. So this is 10 to the 12. 2 to the 400, 2 to the 40 bytes. It's pretty big. Okay, so let's go back to my notes. So a terabyte is equal to a TB, and this is going to be 1,000 times 1,000 times 1,000 times 1,000. Okay, which is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the same as that one. And 10, 11, 12. 12 zeros. Okay. 4. 1, 2,000s multiplied together is a megabyte. 3,000s multiplied together is a gigabyte. 4,000s multiplied together is a terabyte. If you guys want extra credit tonight, multiply out the 1024 times the 1024 times 1024. Okay? Now, let's go and talk about where do they get the 1024 from. Good question. Binary is dealing with factors of 2. Okay? 2, 4, 8, 12, I'm sorry, 16, 32. Keep multiplying by 2. What do you get? 128, 256, 512, and 1024. Okay. Okay, are you with me? Those are all what we call binary numbers. Anything that's multiples of 2 is potentially a binary number. So when you guys see, have you guys know what these are, right? Okay, hard drives, right? You're going to see them in terms of 2 gig, 4 gig, 8 gig, 16 gig, 32 gig. Have you ever seen 27 gigs of memory? No. What was that? Oh, Jesus. 2, 4, 8, 16, 32, 64, 128, 256, 512. We're going to pause station identification. You guys, you're not going to see, like, I'm going to go out and buy 23 gigs of hard drive today. It's not going to happen. Jesus, Mary and Joseph. Oh my God! You never tell. Yeah. Oh God. You're not gonna see like odd numbers. Odd. You're not gonna. I gotta pause. I gotta pause. All right. Okay. We're gonna try to come back to this lesson. It's probably not 500 gigs. It's probably 512. But they'll probably round it down to 500. Are you with me? It's probably not 500. It's probably 512. Do you see this number right here? You're probably not buying 250 gigs. You're probably buying 256. They're in terms of binary. Okay. Now I have seen 3 terabytes. So I have seen an odd number in terabytes. Okay. So who's getting this so far? You guys writing this down so far? You trust me, you need to write this down. Are you with me? If you don't write this down, you ain't going to get it. Okay, so stay with me here because now we got to start getting into how do we read and write binary. So that's kind of the foundation of it. Are you with me? Okay, so let's go back to this. We did? Well, all right, here we go. So let's go back to, are you ready? Let's go back to this. Are you ready? 1 byte is equal to what? 8 bits, okay? And now I'm going to show you how to use your bits. Okay, and now we're going to actually start reading and writing in binary. Okay, are you ready? One byte, B-Y-T-E, gigabytes, megabytes, right? That's how you talk in terms of memory, is 8 bits. So let's say you've got 8 gigs of memory, right? 8 gigs is 8 billion bytes, B-Y-T-E-S, right? How many bits are in there then? Okay, so let's go find, let's go find a thumb drive, right? Okay, you guys know what these are, right? These are thumb drives. So we'll just take this guy here. Okay, number one, do you guys see this guy's 64? Yeah, they're 2 cents. This guy is 2 gigs. You're not going to see 3 gigabytes in here. Are you with me? Um, this guy, I don't even know what that is. This guy's 16 gig. Here's 32 gig. Are you with me? So when you buy 32 gigs of memory, that's 32 billion bytes, B-Y-T-E-S. Are you with me on that? Okay, 32 gigabytes. That's B-Y-T-E-S. You're going to multiply that by 8 to get how many bits are in there. So what is stored in here? Do you guys know what's stored in here? What goes in here? No. What goes in here are these zeros and ones. Yes. You're storing zeros and ones. Are you guys with me on that? This is what goes in here. You have 32 gigabytes times 8 bits. You have a bunch of bits in there. You're putting in there zeros and ones. Okay? If it's an image, it's zeros and ones. If it's a song, it's zeros and ones. Who's getting this? Okay? If it's an image, it's zeros and ones. If it's a song, it's zeros and ones. Are you with me? This is what gets stored in there. All right, let's go back here. Okay, now let's teach you how to read and write in binary. Are you ready? This is how you read and write in binary. Okay, so let me extend the page a little bit. All right, I went a little too far. There we go. I want to keep my 1 byte because you get 8 bits. So, all right. Okay. All right. So, when you're writing in binary, you always want to write down these 8 bits: 1, 2, 3, 4, 5, 6, 7, and 8. Yeah. Put it down at the bottom page. Just keep going down like I am. Make this really big all the way across the page because we got to put some numbers in here. You guys with me on this? All the way across the page. Stay off your tablet. You need to write this down. Now you're going to read from right to left. Americans don't like that. Okay. Does anybody in here know how to read right to left? Like Arabic or anything? No? Okay, there's other countries that read right to left. We don't. We read left to right. So this might be a little different for you guys, but try this. This is going to be 2 to the 0. Okay? This is 2 to the first power. This is 2 to the second power. This is 2 to the third power. This is 2 to the fourth power. This is 2 to the fifth power. This is 2 to the sixth power. And this is 2 to the seventh power. So go ahead and write that down. That's a 7. What? What? Underneath. Underneath. Underneath the line, exactly like I did. Because what's going to happen here, Cross? You're either going to put a 0 or a 1 in here. How are you going to write? Yeah, you're right. That's a good question. How do I write my name in binary? I'm getting ready to show you. It's all going to come together here. Okay? Now, let's do some math on this. 2 to the 0 is 2 to the 0 is 1. Okay? And if you guys ever want to know mathematically, it's because it's when you divide 2 to the 5th, divided by 2 to the 5th. Okay? When you divide, you subtract. So it's 2 to the 5 minus 5. Okay? And 2 to the 5th power is going to be um, it's like 32 divided by 32, something like that. So 32 divided by 32 is 1. Okay, so this is going to be 2 to the 0. So that's the reason why is when you do this mathematically, that's what you get. This is 2 to the first power. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. 2 to the sixth power is 128. Okay. Do you guys see it? And those are all binary numbers. Those are those binary numbers I just showed you. Okay. How many people have this written down? What? Now, let's go back and let's start talking about something we've learned this year. Okay. If I would add up all these numbers right here, right? Okay. If I add up 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 8 is 15. 15 plus 16 is 31. 31 plus 32 is 63. 63 plus 1 or 64 is 127. And 127 plus 128 is equal to 255. Okay? So what's that mean? The largest number I can put in there is 255. Okay? And then that means we can handle the numbers 0 through 255. Yeah, let's go back to RGB. Do you guys remember doing RGB this year? Who remembers doing RGB on the first app we did? Okay. Remember RGB takes in 3 parameters? Okay. And all these numbers go from 0 to 255 in the red. 0 to 255 in the green. 0 to 255 in the blue. Okay. Guess how many bits we need to do an RGB? I need 3 bytes. Okay. I need one of these up here, right here. I need these 8 dashes to do the red. I need 8 dashes to do the green. And I need 8 dashes to figure out the blue color. Are you with me on that? All right. Now, give me a number, since you now know that the largest number is 0 to 255. Give me a number in between there, Mike. 50, go higher. Let's go into twos. Yeah. 250. How about 250? All right, so let's go ahead and convert 250 to go to binary code. Are you with me? We're going to convert it in binary. Are you with me? All right, so you guys don't have to do this. You already have it on your page, but I'm going to do it again. Okay, this is 1, 2, 3, 4. This is how I do it. 5, 6, 7, 8. Remember, this was a 1. This was 2. This was 4. This was 8. This was a 16, 32, 64, 128. Are you with me on that? So, what you do now is you start going from left to right and figuring out what's the largest number I can use to add into 250. Can I add 128 into 250? Yes, I can. Put a 1 there. Can I add up 64 plus 128 to start adding up to get 250? Yes, so I want to put a 1 there. So if I would add these two numbers up, 128 plus 64 is 192. 60 and 128 is 188, plus 4 is 192. Are you with me on that? Okay, can I add in 32? Yes, let's add in 32. Okay, so when I add in 32, I'm going to get 224. 32 plus 192. Check my math on that. Is that right? 224. Okay. Can I add in 16 here and still try to be underneath 250? Yes. Add it in. Okay. You get 240. I think you're right. And now I need 10 more. Can anyone see how I get 10 more? Add 8 and the 2. So guess what? I don't need the 4 and the 1. What am I going to put in there? A 0. Okay. Do you see how I got that? So 250 in binary code is 11111010. Okay? That's how you write 250 in binary code. Let's do another one. Give me another number. Let's go in the 100s now, somewhere between 100 and 200. And 180, we did an even one. Let's do an odd one. 183. Okay, let's do 183. So what is 183 in binary? 1, 2, 3, 4, 5, 6, 7, 8. This is exactly how I do it every time. Are you with me? What number is this? This is a 1, 2, 4, 8, 16. Who's getting this, by the way? 32, 64. Do you see how it's complex? But there's a system to it, and the system can be learned, just like coding, right? Coding's complex, but can it be learned? Yes. Binary's complex. Can it be learned? Yes. And I show you how to do systems. This is how we divide and conquer, break stuff down, okay? All right, so let's go ahead and start this. Can I use the 128 to add in here? Yes. You always start with the biggest number. If you start with the smallest number and go back, you're going to get it wrong. Because there could be different combinations of it that way. You with me? You always start with the biggest number. So I've got 128. Can I add in 64? No. Because 64 and 128 is 192, you went over. Are you with me on that? Everybody understanding this so far? Can I add in 32? Yes. So when I add in 32, I get 160. Very good. Can I add in 16? Yes. 176. Can I add in 8? No, that's 184. You cannot do that. Can I add in 4? Yes, that's 180, right? And how do I get 3 more? 2 and 1. Okay? 2 and 1. So what is 183 in binary? 10110111. Okay. Tonight's homework. Write your name in binary. What? What? How do we do that? How do we do letters? Wow. You don't. You do numbers. No, don't. I'm going to show you this. You got to do it by hand tonight. Can you look it up on the internet? Absolutely don't. Okay, don't be a cheetah. I'll know if you're going to know if you're correct or not. All right, so there's some, go ahead. There's something called ASCII, ASCII Value. Yes. I know it sounds like I'm cussing on tape, but I'm not. ASCII. It's a great word, though. You'd be like, dude, move your ASCII, man. Your ASCII value is in my way. All right, so let's see what this is. Let's see if this is it. Yes, this is it. So, I'll save this image here. Okay. All right, so do you guys see this? All right. Do you guys see this table here? So I want you to go tonight and look up ASCII value table on the online, okay? So once again, this looks like, oh my God, that looks like Japanese, Arabic, and Chinese written all together. It looks very complex, but let's make it simple, okay? You need the left-hand column, and then you need the red thing here, okay? All this red stuff is the characters that you're finding on the keyboard. You have to do 6 letters because I'm giving you 30 points, 30 times 5. Okay, they're all 5 points. And if you want to do more than 6, they're all extra credit. So do your last name, you get extra credit. Yes, ma'am. Then come up with like a middle name or a last name or something. What? Yeah, you can do a nickname. That's fine. Do a name. You can do your dog's name. I don't care. Okay? Bogey. Okay. So, does everybody see this right here? Micah. Okay, I just said go figure it out. 6 letters. All right? First name, last name, middle initial. I don't care. Your dog's names. Trust me, folks, there's a lot of names out there with 6 letters in it. Are you with me? Come up with 6 different letters. All right, so let's learn how to read this. Can everybody read this? Okay, look. Okay, so let's go over here. A capital letter A. Does everybody see this? A capital letter A is 65. Do you see that? A capital letter B is 66. A lowercase a is 97. Lowercase b is... Now, do I want you to memorize this? No. Okay? Look at this. This is interesting, and I think this explains something in binary. Guess what, folks? A 0 is a 48. A number 1 is a 1 is not a 1. What is a 1? A 1 is a 49. Do you understand that? A 1 is not a 1, it's 49. So next time your math teacher puts 49 on the board, you're like, dude, there's 1. I've been looking for 1 the whole time. A 1 is not a 1, it's a 49. An A is a 65, a lowercase a is a 97. So let's go back here, okay? And guys, don't memorize this. Are you with me? Don't memorize this, okay? Because we all know our ABCs. So, you know, all you have to do is, and if you want to, you can write this on your paper like this, okay? A big A is 65. Are you with me? A big B is 66. Capital letter C is 67. Do you guys see the pattern here? Okay, yeah, you guys can keep going. Right? And if you want to make your life simple right now, just go ahead and write your alphabet out and do the math on it, right? So what's a D? 68, okay? So let's go do my dog's name, all right? Now, this is how you're going to do your homework tonight, and you can start doing your homework right now. My dog's name is Bogey. Bogey. Bogey is my dog's name, okay? All right, so what's a capital B? 66. What? Okay, let's go back to our chart. What is a lowercase o? 111. Do you guys see that? So Bogey is a 111. What's a G? Lowercase g is a 103. Okay, what's an E? An E is a 101. Who's getting this? And what's a Y? A Y is a 121. Okay. Now, I've had some students turn this into me like this. Bogey 66, 111, 103, 101, 121. I'm like, dude, that's not binary. What is this right here? This is ASCII value, ASCII. Because you cannot, letters are not letters to a computer. What are they? They're a number. A B is a 66. Are you with me? So now watch. Here's what we get. Here's how we convert this. So I would write this down, and now you do your 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. Are you with me? Watch this. This is 1, 2, just exactly what we just did. Who understands what I'm doing? 32, 64, and 128. Okay, so bogey is a 66. That's a 64 and a 2. That was an easy one, right? Hang on, I'll answer questions here in a second. So that is a capital letter B right there to a computer. 010010. Who understands what I just did? The letter goes into ASCII value. The ASCII value then gets converted to binary. So a B is not a B at all. What is it? It's a 66. Okay? Are you getting me on that? Are you with me on that? Mind-blowing. This is why I told you had to write this down. 1, 2, 3, 4, 5, 6, 7, 8. What's a 111? 111 is 64 plus 32 is 96. 96, I can't add the 16. I can add the 8. That's 104. 104. Lowercase. A lowercase a is 97. B is 98. C is 9. No, uppercase A is 65. Check it. Is my A right? Okay, let's go back here and look. Lowercase a is 97, 98, 99. Are you with me? Lily, question. What numbers am I adding into to get 111? I'm adding the 128, 64, 32, 16, 8, 4, 2, 1, just like we did in binary. So I've got 60 seconds left. Let's finish this, okay? This is 128. This is 64. This is 32. This is 16, 8, 4, 2, 1. So I added in 64, 32, 96, 104, 108, 110, 111. So a lowercase o is a 111. And it's 0110111. Okay? And you're going to do this all the way. You're going to get your G, your E, and your Y, or whatever you're doing tonight. Are you with me on that? Who understands this? Name in binary. Have it done tomorrow. 30 points for your notes. Who learned something today in binary? Have a great day.